trigonometric ratios of some specified angles. So the specified angles which we will take in class 10th are angles of 30 degree, 45 degree, 60 degree, 90 degree and 0 degree. So first we will consider the angle of 45 degree. We will find the trigonometric ratios of 45 degree. For that we will take a right triangle ABC in which one angle is 45 degree. Suppose let us say angle A is 45 degree. Now if angle A is 45 degree, then angle B is 90, and we know that the sum of all the three angles of a triangle is 180 degree. So obviously angle A plus angle B plus angle C should be how much? 180 degree. So angle A plus angle B plus angle C will be equal to 180 degree, and where it will be? In right triangle ABC. Why? Because this is angle sum property of a triangle. So in this angle A is 45 degree. So we will replace angle A with 45 degree. Angle B is 90 plus angle C equal to 180 degree. So 45 plus 90, that will be 135 degree, plus angle C equal to 180 degree. Therefore angle C will be equal to 180 minus 135 degree, and that will give you angle C as 45 degree. Now we are having angle A also as 45 degree and angle C also as 45 degree. That means in a triangle two angles are equal. We know that if in a triangle two angles are equal, then the sides opposite to them are also equal. So here angle A and angle C both are 45 degree. Now what is the side opposite to angle A? That is BC. So therefore we can say that BC equal to, now opposite to angle C is AB, so BC equal to AB. So this is what we will be getting. And suppose let us take the length of BC as A. So length of AB will be also A. So let us take this as say A. Now this is right triangle, so we can apply the Pythagoras theorem. If we apply Pythagoras theorem in right triangle ABC, so this angle B is 90, opposite to angle B will be getting the hypotenuse, that is AC. So if we apply the Pythagoras theorem, we will be getting AC square equal to AB square plus BC square by Pythagoras theorem. So what is AC square? That we will find, but we know the value of AB, that we have taken say A. So we have put A square, also BC is A. So A square plus A square, that will give us 2A square. So what we are getting here is, therefore AC square equal to 2A square. Now we will find the value of AC. Therefore AC equal to, we can find the value of AC by taking the square root both sides. So square root of 2 is root 2 and square root of A square is A. So this will give us root 2A. So in this case we will be getting here root 2A, and this is our A and this is A. So now we can easily find the trigonometric ratios of sine degree, sine theta, cos theta, tan theta by putting the value as 45 degree, because we know how sine is defined. So let us write that. First we will be finding the value of, say we will find the value of sine 45 degree. Sine 45 degree, we know what is, how sine theta is defined as. Sine theta is defined as perpendicular by hypotenuse. So in our consideration we have taken angle A. So angle A we are considering. So sine 45 degree will be equal to perpendicular over hypotenuse. What is perpendicular? Opposite to angle A, the side that will be perpendicular, and that is BC. So that we will be writing as BC over hypotenuse is in this case AC, equal to putting the value of BC, that is A, and putting the value of AC, that is root 2A. So because A and A in numerator and denominator both are common, so we will be getting here, therefore sine 45 degree equal to 1 by root 2. So this is the value of sine 45 degree. So we have derived the value of sine 45 degree. Similarly we can find the value of cos 45 degree. Cos is defined as base by hypotenuse. base by hypotenuse, and for this again we will refer to our figure, that is figure 8.14. So what is base? So the angle which we are considering, that will be involving two sides, so we will not take the hypotenuse. Other than that, other side will be considered as base. So here AC is the hypotenuse, so AB will be the base. So this will write as AB over AC. Now what is AB? You can see the figure, that is A, and what is AC? Value of that is root 2A. So again in this also we can see that in the numerator and denominator both we can cancel out A. So cancelling A, what we are getting here is 1 by root 2. So we can say that therefore cos 45 degree equal to 1 by root 2, and similarly we can find tan also. So what is tan 45 degree? Here you can see that we have derived tan 45 degree. Tan 45 degree is perpendicular by base. So that is how they are defining it, perpendicular. So what is the perpendicular in this case? That is BC. What is the base? AB. So BC is A, also AB is A. So A over A, that will be getting 1. Therefore tan 45 degree equal to 1. And to find the value of cosec 45 degree is very simple. Just we know that cosec theta is the reciprocal of sin theta. So cosec 45 degree will be the reciprocal of sin 45 degree. So what is sin 45 degree? 1 by root 2. So cosec 45 degree will be equal to root 2. Next, how can we find the value of sec 45 degree? Sec theta is the reciprocal of cos theta. So cos 45 degree we have obtained as 1 by root 2. Therefore sec 45 degree will be reciprocal of 1 by root 2, that is root 2. And what is cot 45 degree? Cot 45 degree is nothing but the reciprocal of tan 45 degree. So what is tan 45 degree? That we have obtained as 1. So reciprocal of 1 is 1. So therefore we are getting cot 45 degree as 1. So this is how we can obtain all the trigonometric ratios. We can obtain the trigonometric ratios of 45 degree, which involves sine or cos or tan or cosec, sec, cot, any. Trigonometric ratios of 30 degree and 60 degree angle. For this, let us consider an equilateral triangle. Let the equilateral triangle be ABC. So first construction we will do is we will draw a perpendicular AD. So from vertex A, draw a perpendicular on BC and let that perpendicular be AD. Now we can easily prove that triangle ADB and triangle ADC both are congruent. How we can prove that? You can see that in both the triangle AD is common. Also angle ADB and angle ADC both are 90 degree, and AB and AC are equal. Why they are equal? Because triangle ABC is an equilateral triangle, and in an equilateral triangle all the sides are equal. So we will be getting triangle ADB and triangle ADC both as congruent by RHS. And then because we know that whenever two triangles are congruent, their corresponding parts are equal, so we can say that angle BAD and angle CAD both will be equal, but the total sum is 60 degree. So both will be 30 degree and 30 degree. So now triangle ADB is a right triangle with the acute angles as 60 degree and 30 degree. So we can easily get the values of sin 30, cos 30 and tan 30, and same way also we can get the values of sin 60 degree, cos 60 degree, tan 60 degree, cosec 60 degree, and so on. And how we can get? Just by applying the definition of sin, cos and tan, or say cosec, sec, any. So let us do this one. So already we have seen that these two triangles ADB and ADC are congruent, and suppose let the length of say this equilateral triangle be 2A. So this 2A, and because triangle ADB and triangle ADC are congruent, therefore length of BD and DC will be equal, and total BC is 2A. So this will be A and DC will be also equal to A. So now let us go in right triangle ADB. First of all we will find the value of because we are not having the value of AD and AB. AB we are having in terms of 2A, in terms of A, but we do not have the length of AD in terms of A. So how we can get that? We can get that easily by using Pythagoras theorem. So let us go in right triangle ADB and obtain the value of AD in terms of A. So in right triangle ADB, so if you apply Pythagoras theorem, what we will be getting? AB square is equal to AD square plus BD square. This is by Pythagoras theorem. So what is the value of AB? AB is 2A, so we will put the value of 2A here, 2A whole square equal to AD. AD is not known to us, so that we will write as it is. BD is A, so we will write A square. Solving this, we will be getting 4A square equal to AD square plus A square. So this will give us, therefore, AD square equal to 4A square minus A square, that is 3A square, and taking the square root both sides, we will be getting AD equal to square root of 3 into A. So that is what we will be doing here. We will write in place of AD, we will write root 3A. So now let us write the value of AD as root 3A. So we have written the value of AD as root 3. Now we will find the trigonometric value of say sine 30 degree. So for that, we know how sine is defined. Sine 30 degree is equal to, that is perpendicular over hypotenuse. And if you see the figure, the side opposite to 30 degree will be our perpendicular, that is BD, over hypotenuse. In our case, we are taking right triangle ADB. So we are working in right triangle ADB. In right triangle ADB, so hypotenuse is our AB, so BD over AB. So what is the value of BDA over AB? What is AB? 2A. So in both the numerator and denominator, we can see that A is common. So what we are getting here is 1 by 2. So the value of sine 30 degree is equal to 1 by 2. So therefore we can say that sine 30 degree equal to 1 by 2. Now similarly, we can obtain the value of cos 30 degree. So what will be cos 30 degree? Again, we know how cos is defined. Cos is defined as base over hypotenuse. So we are not changing the triangle. We can work out in triangle ADC also, but we are working right now in triangle ADB. So cos 30 degree is equal to base. So what is base? So this is our angle 30 degree, that is angle BAD, other than the hypotenuse, the other side, that will be considered as base. So AD will be our base. So AD over hypotenuse. What is the hypotenuse? AB. So cos 30 degree equal to AD over AB. AD is root 3A over hypotenuse is 2A. Here also we can see in the numerator and denominator both A is common, so that will cancel out, and what we are getting is cos 30 degree equal to root 3 by 2. So cos 30 degree equal to root 3 by 2. Now next we will find the value of tan 30 degree. Now we will find the value of tan 30 degree. Tan 30 degree equal to perpendicular by base. Tan theta is defined as perpendicular by base. So in the right triangle ADB, what is perpendicular? That is BD over base. What is the base? That is AD. So value of BD is A and value of AD is root 3A. Here also we can see that in both the numerator and denominator, one, that is A, is common. So what we will be getting here is equal to tan 30 degree will be equal to, let us write 1. So we will be getting, therefore tan 30 degree equal to 1 by root 3. So this is what we have got, tan 30 degree as 1 by root 3. Now it is very simple to find the value of cosec 30 degree, because cosec 30 degree will be the reciprocal of 1 by 2, that is reciprocal of sine 30 degree, so we will be getting 2. Similarly, sec 30 degree will be equal to reciprocal of cos 30 degree, that is 2 by root 3, and tan this cot 30 degree will be the reciprocal of tan 30 degree. So we will be getting the value of that as root 3. And also you can obtain with the help of the same figure the values of sine 60 degree, cos 60 degree, tan 60 degree, and that all. So that you will try on your own. Here already it is given also. So if you refer to the textbook, you can find the values of sine 60, cos 60, tan 60, cosec 60, and cos 60 degree. That all is given. And how you will obtain? by the same method as I told you. For example, let me clarify this: sine 60 degree, that is equal to perpendicular by hypotenuse. So what is perpendicular in this case? Is 60 degree. Perpendicular is AD, and what is the hypotenuse? AB. So we are getting AD over AB as sine 60 degree. So what is AD? AD is root 3a, and what is AB? That is 2a. So we will be getting root 3a over 2a, and a can be cancelled out. So we will be getting the answer as root 3 by 2. So similarly, you will find the value of cos 60 degree, tan 60 degree, cosec 60 degree, and cot 60 degree. So that you will be doing on your own. Also, if you have any doubt, you can see the textbook is already given in that one. And now let us go in this other ratio, that is trigonometric ratios of 0 degree and 90 degree. So it is very simple one. You can see that this is figure. So as the angle, suppose let us consider angle A. When we are going on reducing the angle A, it will become less and less, and when this point C in triangle ABC, then when C will coincide with angle B, what will happen? Angle A will become 0 degree, and in that case you can see that opposite to angle A, what is that? That is known as perpendicular. So the perpendicular will be 0. Let us go in the next page. So in that case, when here you can see that when angle A equal to 0 degree, in that case perpendicular, that is BC, will be equal to 0, and the hypotenuse will be equal to, hypotenuse AC will be equal to AB. So now it is very simple to find the value of the trigonometric values. So let us find the value of sine 0 degree. Sine 0 degree will be equal to, sine you know is defined as perpendicular by hypotenuse, that is BC over AC. But what is BC? That is 0 over hypotenuse, that is AC. So 0 over AC, that is 0. So sine 0 degree is 0. And let us find the value of cos 0 degree. Cos is defined as base over hypotenuse. So what is base in this case? That is AB. What is the hypotenuse? AC. But here we have already got that when angle A is becoming 0 degree, the hypotenuse and this base both are becoming equal. So in this case we will get this AB we can replace with AC. So we are getting AC over AC equal to 1. So therefore cos 0 degree equal to 1. And what is tan? Tan you all know, tan is defined as perpendicular by base. So perpendicular by base. What is perpendicular in our case? That is BC over base. Base is AB. But what is the value of BC when angle A is 0 degree? So in that case it is 0. So 0 by AB. So we are getting 0. And easily, as discussed earlier, you can get the value of cosec 0, sec 0, cot 0. So that you will be doing on your own. And similarly, we have another case when the angle A, when angle A will become closer and closer to, when the vertex A will come closer and closer to the vertex B. In that case, this our acute angle A will become 90 degree. So let us take that case when A is approaching towards B. So this is our next case. In this we can see that the angle, here you can see that the vertex is approaching near and near to B. As A approaches to B, we can see that the angle A is become bigger and bigger. So in that case we can see that angle A will become 90 degree when A and B coincide. So that is what we will write: when A and B coincides, when A and B coincides, then in that case angle A will be equal to angle B equal to 90 degree. And also in that case what you can see here, that is the perpendicular, the base is becoming 0. Base AB, base equal to AB equal to 0, and also the hypotenuse is equal to the perpendicular, that is AC will be same as BC. So when this is going to happen, when angle A, that is acute angle A, will make bigger and bigger and make it equal to 90 degree. In that case we can see that as angle A will become 90 degree, the base will become 0 and the perpendicular will be equal to the hypotenuse. So we can easily now find the values of sine, cos and all that. So let us find the value of sine 0 degree. Suppose sine 0 degree, sine 90 degree, because we are considering angle A in this case. So we will be finding the value of sine 90 degree. Sine 90 degree equal to, how sine 90 degree is defined as, sine theta is defined as perpendicular by hypotenuse, perpendicular over hypotenuse. So equal to, what is the perpendicular? BC. What is the hypotenuse? AC. And we know that, as we have seen here, we discussed, when angle A is becoming 90 degree, in that case the hypotenuse is becoming same as the perpendicular. So we can replace this BC with AC. So we will be getting AC over AC equal to 1. So therefore we can say that sine 90 is 1. Therefore sine 90 degree equal to 1. Now what is cos 90 degree? Cos 90 is defined as base by hypotenuse, and we have seen here clearly that when angle A is becoming 90 degree, in that case base is equal to 0. So we will be writing 0 over hypotenuse, or 0 over, you can write AC. So answer will be 0 because hypotenuse is non-zero. Now same way we can find the value of tan 90 degree also. Let us find the value of tan 90 degree. Tan 90 degree is, tan theta is defined as perpendicular by base. So what is the perpendicular in our case? That is BC. What is the base? AB. But as angle A is becoming equal to 90 degree, the value of AB is 0. So BC over 0. But we know that if you divide any number by 0, it is not defined. So tan 90 degree in this case will assume the value of, it is not determined. So not defined. So similarly now you can find the other values, that is the value of cosec 90 degree, sec 90 degree and cot 90 degree, that you will be doing on your own. Also it's not difficult because you know the definition for that, and here we are having that table. So you will obtain all these values can be obtained, and you can make a table like this. So this table will help you in performing questions in which trigonometric angles values are required. So learn them, by heart them, they will be very helpful to you.